Good morning. Thanks for the welcome. This is a project that we started about 4.5 years ago. Was hired by a group of fire companies to come up with a new system. They currently were using, at that time, a system that consisted of 6 simplex base stations around their county. And it had a lot of problems with it. Lack of coverage from multiple bases. They were constantly dispatching fire departments on the wrong base station. They were paging them on the wrong base station and having a lot of problems with it. And they wanted to do something different and hired me to come in and take a look at what they were doing and what they could do to change it. And of course, we were also looking at narrowbanding at that time. And their equipment was getting to the point of being about 20 years old. So we came in, did some studies, and worked a new system solution for them that consisted of 7 sites instead of 6. And because they were already using UHF links to control their VHF simplex transmitters, we went along with the idea of using the UHF links for simulcast, which, from what I understand, is something that has not been done very often, if at all. And it presented us some problems, but Ed was good enough to help us out with some of the design characteristics in doing that. The county had already established that sites would be utilized, that the existing sites would be utilized for the system. We verified the suitability and selecting the sites, and the county assumed overall coverage responsibility. We had to assure seamless coverage. As you can see, the county is quite hilly. This is a 3D graphical representation of the county. There's a couple of river basins in the county. There's 2 large lakes, many small lakes, along with a considerable amount of forest, low population density, and overall presented some terrain problems, and of course their simplex operation presented them with additional problems. Some of the tower representations on there were our test tower sites and so forth that were on the picture that I supplied. This is a representation of what they had with 6 sites, and part of the problem was up in this area here. There's a department up there that had less than 50% coverage of their area, and we had another area down in this part of the county that coverage was very poor, especially for pagers and portables. The fire departments wanted to design coverage for portables and especially pagers. But the portables was a big consideration. During my information gathering at the very beginning, I stressed to them that portable radios or any radio inside of a tin can does not work very well. And simulcast would help with some of that, but it would not alleviate that problem completely. So they said, well, go ahead and see what you can do with it. So we went and came up with an alternative plan. We added a station down in the south part of the county, which pretty much cleaned up that southwest corner. And we took the station that was up in the northwest part of the county and moved it slightly. And we moved the one from the northeast part of the county, we moved it to the west a little bit. And we shifted the bad area up in here slightly and gave them a very good coverage, and we've got good coverage in that area now, and implemented the system with 7 base stations. We designed the system basically around Kenwood transmitters. The TK R850s are the link repeaters, and that's basically a diagram of what the central dispatch and central unit looks like. The remote sites basically are a pair of crossband repeaters. And again, we're using the CTCS filters at each site. When we staged the system in the shop, I calculated, I got the formulas from Ed. We calculated the delays and laid them all out. I put the paper in my desk and I handed the problem off to my service manager. And he calculated the delays again and showed me what he had done, and I compared the two and they were identical. So we decided that was probably a fairly good place to start. We staged it in the shop completely. We entered the calculations we had into the equipment, took it out, installed it, and have not made a change to any one of those delay calculations, and the system is working fine. This is a photograph of the central dispatch situation, and you can see all the combiners in the rack. We used 100% EMR combiners, and the UHF repeaters for the links. We have 6 links. We have the central dispatch has got a UHF receiver on it so that we have the delays built in for the central dispatch site, but it's not a full-blown link. We're linking into one of the other systems. We use the audio distribution amplifier like you saw in the earlier presentation, and that thing is remarkable. And all of the repeaters are all Kenwood, either TKR 800s or 740s. We use the Spectracom GPS master oscillators with the CTCSS generator, which is probably a better name for that box than a filter. The Convex delay lines, and as we said before, here's a block diagram with the cable connections and the pinout numbers for the various units in the sites. And Ed asked me to supply the pin numbers so that it would be easy to reference these, and if anybody has a system that they're going to be working on similar to this, that part of the project is done.
Quick question on that. The link transmitters going both directions, are they upkeyed all the time, or do you just keep them up?
We key the site transmitter all the time to hold the frequency. Just similar to what you would do if you were doing it on a phone line. All of our links are 2 watt, and the licenses were in place when we did them. And they're site-specific licenses and tower-specific, and some of them are more than 25 feet off the ground, as per the licenses. We are not concerned and have not been concerned about maintaining the frequency stability on the link units. We've got outputs from the GPS oscillators, and we're using those where we have them available. Central dispatch, of course, there's not enough outputs to have them all synced, but it has not been a problem, and we got very, very stable situations. A couple things that we learned and like to pass along is, number one, make sure the jumpers are all set exactly the same. We had one jumper in the CTCSS filters. Well, we had one filter that failed in the shop. We sent it back to the manufacturer. They called a couple days later and said, we can't find anything wrong with this thing. But we're going to leave it on the bench and test it for a couple more days, and we'll ship it back to you if there's nothing else. They called me back and said, no, there's nothing wrong with it. They shipped it back to us. We got it back. We put it in one of the sites, so we were building it in the shop, and it tested okay, so we went with it. We assumed that the jumpers in that box were all set the same in all the boxes. It was a bad assumption to make, because there's a phasing jumper in there for the upper frequencies and the lower frequencies. And we had a terrible time. We tried everything to get that system to sound right, and it wouldn't sound good. We tried offsets, we tried adjusting power levels, we tried everything, nothing. So finally, I got on the phone with Ed and my service manager, and we wrestled with that thing for about an hour one morning, and Ed came across and says, what about this jumper? You know, we got one site that seems like it's really messing the whole thing up. So we off to the sites and checking, and the one site that was supposedly messing up was set correctly. But when we went and checked it, we had 6 sites that were not. So it took us about 12 hours to reconfigure the system. Had drive to each site, reset them, take all of the, restore the power to all of the outputs, take all the offsets out, and reset the oscillators. And the oscillators take a long time to finally get back on frequency. Took about 12 hours to get the whole thing back up, and once we did, it was all working fine. It was the one problem we had with the system, and we pulled our hair out with it, but we finally got to the end of it.
This jumper was in which piece of equipment?
Pardon?
The jumper was in which piece of equipment?
It was in the CTCSS filters. Number 2 set all audio level throughout the system the same. We set ours at 1.5. One level we did not set that way, and that was the final modulation level in the VHF transmitters. We set for 1.7. It's worked fine. We've had no problem with it whatsoever. But those levels have to be the same throughout the entire system. With the distribution, or with the PTT box, that really makes it easy. Never overdrive any audio levels. That will mess you up greatly. And there's a photograph of the Berry County Central Dispatch System. And I thank you. That's my presentation.